Today we're going to look at the area of different quadrilaterals and how it relates to the area of a rectangle. If you will recall, the area of a rectangle is the same as doing the length times the width. In other words, we could do 5 times 3, and we would come up with 15, which makes sense because if you count, there are 15 square units inside this rectangle. But what if we have a shape like this? It's still 5 units long, but I can't use the measurement of this slanted side because it's not the same as the height. Instead, I would use this line. I just start at the bottom and count my way up. 1, 2, 3. You may be asking, but what about this shape here? And what about this shape over here? Well, this shape can be moved. We could cut that off with a pair of scissors and slide it right over here. And now we have the exact same rectangle we were dealing with here. We just slid part of that quadrilateral over here. And we end up with 5 times 3 again, which is 15. So for our parallelogram, we would do base, which was the length that was on the bottom here, times the height. Now we have a trapezoid to work with, and I think you'll find it's very similar to our parallelogram. We have a base and we have a height. We don't want to use these slanted edges. Instead, let's see if we can reconstruct this into a rectangle. The first thing I would do is to cut off this little triangle on the end. And I notice I have a triangle that's 1, 2 units by 1, 2, 3, 4 units. Look over here. I've got space for a triangle that's 2 units by 4 units. So I could just put it over here. Now I've got a regular old rectangle. How do I find the area of a rectangle? I do base or length times width. 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4. So we get 34 square units. So for a trapezoid, we would also do base times height.